oxidation, I'm under the impression, has a big part in the cause of cancer also. Is that like free radical oxygen? Don't they say oxidants, like antioxidants help pull free radical oxygen molecules, not molecules, I guess. Are they molecules, atoms, out of your molecules, out of your system? And that when there are a lot of free radical oxygen, is that not a precursor to cancer? Or do you know what causes cancer? Do they know?
Sure. So it's definitely multifactorial. You definitely have to have a change in your DNA that's going to, some sort of mutation that's going to cause, that's not going to be repaired. And it's going to be the deleterious area encoding a protein that's such that that protein won't function properly. And oxidation does play a role in disease. The problem is there was a trial of vitamin supplementation and antioxidant supplementation for many years to see if it would make a difference, and it didn't. So it looks like taking a lot of antioxidants may not help in terms of cancer incidence or survival. It's not to say that it's bad, but it's just a lot of people had this hope that taking a lot of vitamin C and vitamin E and other antioxidants would help. Same thing with resveratrol, which acts as an antioxidant and helps, I think it's raise levels of sirtuin 1 and 2 for anti-aging. They've shown some effects in mice, but the effects so far in humans don't look that promising. So yes, their oxidation plays a role. DNA mutations play a role. For example, in skin cancer, ultraviolet light causes mutations in some DNA bases, which normally can be repaired by your DNA polymerases that are roaming around, or they could happen in an unimportant part of your DNA that codes for a part of a protein that doesn't affect its function. But if it's not repaired and it codes for an area that hurts a protein's function, that can lead to cancer. And your immune system is also very important in keeping cancer at bay. So people who are immunosuppressed start to see more cancers. People, for example, with HIV began to get more Kaposi sarcoma and so forth due to T cell suppression, because your T cells are very important in keeping cancer in check.
Now, if you hadn't gotten ahead of it and you actually did develop cancer, is there anything you can do right away other than, or in addition to, just the extreme stuff that they put people through, chemo and radiation? Do you have any belief at all that there's any alternative to that stuff that can help in any way?
Well, you make a good point, because chemotherapy, well, it's made great strides in certain cancers like childhood leukemias, where you can get a 99% survival rate. For many cancers, it hasn't been very promising, some of the advanced lung cancers. That's changing with some immunotherapies. Some of these therapies where you tailor the therapy to your own T cell response to the cancer, like CAR T, those have been promising, but they've been done in very small studies. And one of the complaints was, I think, a doctor at University of Pennsylvania who was curing some patients with very advanced cancer using their own T cells. And he said, I just can't get funded by the FDA to go on, or the NIH. There doesn't seem to be a lot of interest. But that was quite effective because it was more immunotherapy targeting your own cancer. In general, though, sorry, go ahead.
Yeah, so I'm just, in general, tell me, but I also wonder why. Why are the one thing preferred over another?
That's a great question. So, I mean, you could look at it kind of cynically and say, if it's not by a major drug company, perhaps that's why FDA and NIH are less interested. I hate to think that's the case. I would like to think that they're most interested in helping people, but that is an allegation that's been raised. In general, there have been, because chemotherapy is disappointing for a lot of surgeries, and of course, if you have a large tumor that needs debulking, then surgery is quite important. For example, if you have a glioblastoma in the brain, you may need some surgery or some radiation to shrink it. But the problem is it's still going to keep growing. So you need something that's going to target it, and it has these diffuse feet that go into the rest of the brain, and they're very hard to eliminate. So in those cases, you need some kind of targeted immunotherapy or something that's going to kill the cells based on a cell surface marker, or this thing called a gamma knife, where you can do very precise radiation. Yeah, those are more effective than just a generalized debulking by a neurosurgeon.